Hello, Shinjue. Hi, can you hear me? Let's see. Hi, Alex. Hi, Harrison. Hi, Jacques. Hi, Celine. Welcome, everyone. Let me get, I think the YouTube stream should be okay. Let me just check, make a speed test check real quick. Hmm, 21 megabits per second. Maybe not. All right, I'll upload the YouTube video later. Okay, let me share my screen. All right. You ever see my screen?
Yes, Professor.
All right, so let me bring up the Java. Today we're going to be talking about the Java part of this. So this is actually open. Genenzi. Web dev 2021. And the Java side here is this one. Say open. All right. All right, so let's first see our syllabus, see where we are. Okay. All right, let's see. Right, so we're getting started on our 10th week. Wow. We got about a month left to go. Let me also open the chat, see if anybody has any questions. Let's put that on the side. Oops. Okay, let's see. There's a couple questions on the chat. I'm not going to go YouTube live on YouTube. I'm just concerned that the network might get slow. So I'm going to instead upload the YouTube video a little later, okay? Also, there's a question on clarification on milestone assignments. P1, P2 are required and would be graded now by their due dates. Yeah, so P1, P2, P3, all those assignments, basically, well, I mean, most of them are that you're going to be meeting with your TAs and demoing your prototype, demoing where you are, demo number 1, demo number 2. So our intention is that you would get full credit for those, right? Regardless, right? You know, you would just not have. The only way you could get 0 or get less than 100 is that you clearly haven't done anything, which I don't believe any of you are in that. None of you are like that, right? So you have all that are working on your projects. You have been thinking about this, and that you'll have something to show for in your prototype in demo 1 and demo 2. So our intention is to give you full credit for all those P1s, P2s, P3s, P4, and if you are falling behind, certainly please reach out and we will help you get up to speed and see where you are. But yeah, says, hi, Professor. I just want to confirm if we have class on Wednesday. What's going on Wednesday? Why would we not have class on Wednesday? On the calendar? What do we got on the calendar on Wednesday? Oh, there's a care day. There's a care day. That right. Oh, huh. No, we were explicitly told not to have class on care days. So no, I'm sorry, but we won't have class on Wednesday. I will be holding office hours, nevertheless. So instead of having classes, I will be holding office hours. If you want to reach out, probably I'll have it during the same hours of class. So if you have any questions, please come and we can take a look at that. So yeah, no class on Wednesday, right? Instead, I'll have office hours then. Another quick questions are our assignments 5 and quiz 4 for us both due tomorrow. The quiz 4, yes, it was available this morning, and it will be available throughout the day today and then up until tomorrow at midnight. Assignment number 5. Assignment number 5. Yeah, I mean, you know, I'm sorry that the generic server has been going down. I look at a lot of the requests that are coming through. Some folks are entering in an endless loop of hitting the server continuously and bombarding the server, and the server just times out and quits responding to so many queries so quickly. I'm thinking of different solutions to that would have the minimum effect to everybody. But yeah, I mean, you know, it's responding like a denial of service attack, where you overwhelm a server with repeated requests, and then it just makes that server unavailable for everybody else. So yeah, so we're working towards a fix for that. We're thinking is maybe where we can make sure that folks can't send requests so quickly that it would be buffered, so that, you know, if you have any requests within say a second or two, we would just ignore any requests from the same person. But we're still working on that because we see that obviously it's just making it harder for everybody else. But yeah, that's still to come. So anyway, I've moved the due date to Wednesday, so that just to give you a couple more days because of the service has been down. Nevertheless, we are going to be moving to the next assignment to get you going with that. But yeah, the due date has been moved to Wednesday because over the weekend the server was down and a lot of folks were trying to finish off and they couldn't. Sorry about that. Wednesday, I believe. I believe I moved it to Wednesday. For A5, yes. A5, yeah, so also, so P1 and P2, P3, all those assignments are mostly to give you an idea of where you should be for the milestones that you should be at by those dates. And yeah, you're going to be meeting with the TAs. So there's no hard due date on those P2s, P3s, P4. The idea is that you would schedule with the TA to demonstrate your prototype and your demo 1 and demo 2 within the week that is shown there for the due date. So that week you should meet with your TA for about half an hour or so and get some feedback from them. But they're not hard due dates, right? They're all suggestions of where you should be around that date. Oh, I said Tuesday. Okay, I must have misspoke. It was Wednesday. All right, so let's see where we are. Let's see the syllabus. Yeah, so we're getting started on week number 10. So up to this point, you know, we have taken a look at how to create user interfaces, how to interact with RESTful services, also with a database, but not your database, right? We've been using my generic server, which indeed behind the scenes is using a database. So what we want to learn is how is it that you would store your own data in your own database, right? So we haven't done that. We kind of started that with first creating a controller, a RESTful controller that would allow us to expose a data model so that it could be accessed from your client, from your React client, right? Where you can send data across the wire to a server. The server can convert the JSON data that is coming from the React client, convert it into a Java data model, and then we need to store it somewhere. Right now, we've been storing it in a simple array of widgets, right, in the memory of the server, and it's worked, right? We've been able to implement all the CRUD operations. We can create new widgets. We can remove widgets. We can retrieve all the widgets. We can filter by the parent widget, right? We can update it, delete it. We can do all sorts of CRUD operations. But this is on the RAM, right, of the server, okay? And so it's not permanent storage. If the server reboots, you lose all those changes, right? So we want to make it a permanent solution. So what we're going to be looking at today is how is it that we can make that storage permanent, right? We're going to create a relational database that we can then connect to make that storage solution permanent. Let's see, there's a question, Alex. It's written on the description that we should include Google Doc in the README and the repo. So I assume we need to submit repo. Yes, for your project, you do need to come up with with repositories where you're going to have your source code. Now, typically, you will need repositories for the server side and for the client side. And for the client side, you're either going to be using a Java solution or Node.js solution. And for the front end, you would either be using React.js, or some folks are exploring using Vue.js, and some folks are exploring how to use Angular.js, which is totally fine. But usually it'll be two repositories. And on one of them, I would choose the front end one. You should put a README in there that describes your project, or at least has a link to some Google Doc that describes the project. You could decide to just have it inside of the README instead of having a separate Google document. But I think it's easier if you have a separate Google document. It's easier to edit. You don't have to do commits and anything like that. So it's easier to do that. And this is mostly for you, right? And you should have that project, very, very pretty. That GitHub repository should be very self-explanatory. Especially for potential employers, right? That you could use your repository as a showcase of what you've been working on, projects that you've worked on, that you've built, and ideally you would have some demo, some link of where the project is deployed, so that folks can come into the repository, click on that demo, and then see it deployed on either Heroku or AWS, or even instructions on how, if they want to see that implementation and run it locally in their machine, there should be instructions there for them to, maybe clone it down, install it, and then run it locally in their machine. Professor, is there a server facing some denial of server attack in the HTTP? Can we host everything on our server? Yeah, let's talk about that offline. Okay, so let's move on. Let's see. Right. So let's talk about the database. Okay. Right. So as part of learning how to use the database, right, we're going to be following these instructions over here. Right. This is the assignment for this week. Right. Persistent data in a relational database. Right. And I think this assignment will be simple in the implementation, right? But it might be a little challenging on the setup, making sure that everything is working, okay? And what we're going to be doing is that the widgets that we had started working last week, by the widget Java that we worked on in the previous assignment, we're going to take that data model, right, and have it be stored in a relational database, okay? And it's actually fairly simple. It's just, what might be challenging is perhaps maybe making sure that all the configuration and everything is plumbed correctly, right? Once that is plumbed and the plumbing is all done, all set up, right, the actual implementation is very trivial, okay? So the way we're going to do this is that we're going to take the Java data model, right? We're going to take the Java data model. So let me show you. which is this one right here, widget. Okay, this is the data model that we are working with right now, right? We have the widget that has an ID. It has a string for the type, for the size, the text, all sorts of things in there. Okay, and maybe we can add a couple other things, right? Maybe we can add width and height. Okay, and maybe we should add some the code for this as well. We can generate the setters and getters for this. So this is what we worked on last week. Okay. All right. So what we're going to do is, if you notice here, there's a resources, and under the resources is an application.properties, right, which currently is empty. See that? So here is where you can configure that you want your data model, any Java class that you want to store in a relational database, you can configure it to happen right here. Okay, so let's take a look at how that is configured. All right, so if you go to the modules, oh, here we go. We go to the modules and look at the Java persistence that we should have covered late last week, but we didn't. So we're slightly behind there. It has the following configuration. Okay, we're going to be using a technology called ORM, right? And ORM stands for Object Relational Mapping, meaning we're going to map, right, objects, right, implemented in Java or C# or any object-oriented programming language you can think of, right? All those objects that are implemented as classes, they can be mapped to a relational world, right, using this technology, right? Relational world meaning a world of tables and rows implemented in a relational database such as MySQL. Okay, it's a technology that is widely used in all sorts of infrastructures, right? There's ORM frameworks for every single language you can think of, you know, for PHP, .NET, Python, Java, C#, C, right? Any language you can think of, there is an ORM solution. We're going to be using the standard implementation for the Java programming language, which is called Jpa. Jpa stands for Java Persistence API. Okay, and the way it works, right, is that you can configure in your application .properties file, you can configure the following. You can just copy this. I think, well, I'm missing a couple things here. Let's copy this, and if you put it inside of your properties file, right? Let's copy a couple things here. Copy and paste it here. You can configure that I want to be able to connect to a database, right? You can say the URL of your database. So for instance, we're going to create a database. It's we're going to be using MySQL database server, and which you can say, you can tell where is this running? Where is your database running? So it'll be running at some IP address. Right now I have it running on my machine, which is just localhost. So we can just say localhost. And my server, my database server, which is MySQL, is running at port 3306, which is the standard port. I actually have a database called Your Schema. It's just so that this code actually works out of the box. And I actually have a username and password called username and your password. But you would create your own database with your own username and your own password. And then you can configure, you can copy this configuration so that your server, right, the same server that is providing access to your widgets, can log in with to your database running at this port, right, at this IP address, using your username and password here that you configure here. It'll log into your database and start interacting with the database. Okay, you just need to tell it what is it that you want to store in the database, right? And what do we want to store? We want to store widgets, these widgets. Okay. Right, so let's head over to the database that we're going to be using, right? So if we start off MySQL, obviously you'll need to get MySQL installed on your machine, right? And once you're in there, you can create a connection to the server, Or you can say new connection, and I'll call it web dev, sp21 and section 01. Section 01 connection. Well, I'll leave it like that. Connection. There's a host name. That's the local IP of my machine. 127.0.0.1. That's the same thing as localhost. The username I'm going to use is root. Actually, no. Let me use your username. And I'm going to test the connection, and the password is going to be your password. All right, successful. So that logs me in. That's going to log me in. I'm going to say OK. And where is it? There it is. Let me just bring it up here. So if I click on it, it logs me in. I'm in I'm now connected to the database server, and I have all these schemas on the left-hand side, or databases, right? Let's create one for this course, okay? And so I'm going to say we're going to create a brand new database, and I'm going to call it web dev. I'm going to use the same name I used earlier, right? So it'll be sp21. Actually, no. What is it? Web like that. Web dev sp21 01, and then schema. Right. I'm just going to copy it just so I don't forget it. I'm going to say apply. So this is the database that we're going to be using. Right. We're going to be storing all the data in here, and there it is. There's nothing in it right now. There are no tables. Right. There's no data stored in there. Perfect. Okay. Let's head over to the server, to the Java side, and now we can configure the application.properties. We say that the schema that we're going to be using is this brand new schema that we've just created, web dev sp2101 schema. The username that I'm going to be using is your username and your password. I actually have a user call that, right? So if you go here and if you go to management and you go to users, here's where you can create your users' username and passwords, right? I actually have a user called your username, and the password is your password. You will create your own username, your own password, and that's the user that you want. Now, whatever user you create, you should give it DBA roles, okay? So that it has access to do everything, right? Insert, update, delete, retrieve data, do everything, okay? And you'll create it and then use that account, okay? All right, so right now we don't have anything in the database, right? It's empty. There are no tables. I can refresh here and notice that I have no tables. Okay, so what do we want to store? We want to store these widgets. Okay. Well, normally, if you are savvy with databases, you would start off with creating a table in the database, right? And then making sure that this connects and stores data in there. But there's a much easier way of doing it, right? You can start off with the data model, and you can use the ORM library that we're using. We're using Jpa. Okay? And the way you can do this is that you can say at entity, and okay, it's not finding it, so I guess I need to do a couple more configuration. Let me head back to my to here. Okay, yeah, I need to do a couple more things. I need to make sure that in the POM file, I have to make sure that I have JPA. Apparently, I don't have JPA in here. So yeah, so make sure that you have at least Java version 8. Let me head back to my project. Let's open up my POM, and let's see what I have. Okay, so I have at least version 11, right, which is fine. Okay. And just looking here, and there is no configuration for connecting to a database, right? We only have web and tests. Those are the only two things that are installed in my project, right? So we'll need to install a couple more things. We'll need to at least install the MySQL connector. We need to download the libraries that will allow Java to connect to the MySQL server. Okay, the MySQL connector Java is the standard library that allows me to have Java communicate with the database server. So I'm just going to copy that. And anywhere inside of the dependencies, you can just drop it in there. Right, so we'll do that. Right, so that's going to download the libraries for Java to connect to the database. And we need to also bring in the Jpa configuration. Right, this is going to download the Jpa libraries that will allow me to map my Java data model to a relational model. Right, so if we copy that and we pasted it somewhere in here, okay, hopefully we should be good. Right, let's head over back to widget and let's try this again. Maven projects need to be imported. Okay, so let's import changes. So it's parsing now that POM file. There are new changes. Noted that it's downloading JPA. There it is. See that? It's downloading the JDBC stuff, all the libraries, and it's copying it into its local cache of Java archive libraries, jar files. Okay, so it's still downloading a few things. Okay, it looks like it's done. Right, so let's try this again. So here in the widgets, let's try using that annotation. Right, these annotations are not standard, and you need to explicitly download these libraries. Right, so we're going to say at entity. Now notice that entity is now there. See that? If I click on it, notice that there was two versions of this. There was two versions. We want this one, the one under Java X. Let me just show you again. Right, so notice that if I type here entity, see that there's a org hibernate. We don't want that one. Okay, notice that it has a slash through it, means that it's been deprecated, right? So don't use that one. So it's this one, Java X persistence. So this is the standard library, and what entity does is that it annotates, right, this Java class, right? This is an annotation. That's the at here means that this is an annotation, just like we use the annotation for the widget controller, right? Right, we have this this at, well, there's one that applies to a class. So this is an annotation called entity that applies to this class. It says that this class, we are intending to map this class to an equivalent table in the database. Which database? The one that we have configured in our properties file, that database. Okay, this one, the one we just created. Okay, so by default, right, this is going to try and create a table called widget. Okay, all lowercase. That's the default, right? And so there are two requirements. One is to annotate the class with at entity, and the other thing that it needs to know is usually tables will need a primary key to uniquely identify each record. Right? In Java, it's not as needed. Okay, but we created the ID only because we knew that we wanted to store this in the database, right? So let's because this is going to be stored in the database is going to want this to be a primary key. Okay, and so the way we annotate this to be a primary key is that we use another annotation called ID. There it is. So it's this one, Java X persistence ID. All right, there it is. So that's all we really need. Okay, we need to annotate it with entity and tell it which field is going to annotate to a column in the table, right? And this will create for us, right, the table, right? If we run this now, you'll notice that it will try to log into a database and look to see if there's a table called widget. If it doesn't find a table called widget, it will create it. Okay, notice that down here at the bottom is going to show the create statement. See this? Right, that is the create statement that it used to create it. So I'm just going to paste it down here. I'm going to paste it down here just for documentation purposes. I'm going to paste it. So it created a table called widget, right, with the primary key called ID. Notice that it declared it as primary key. Notice that it created the height, the width integer, size integer, text varchar, topic ID. Notice that in Java, the name of the field is topic ID. Where's topic ID? This topic ID. Where's topic ID? Huh? Where'd it go? Oh, there it is. And so the naming convention, it's even smart enough to tell that in Java, the naming convention is that it's camel case, right? Where we capitalize the first word, the first letter of each word, right? Except the first one, right? But it knows that if Java is case sensitive, so this capital ID makes sense. But in MySQL, right, in SQL in general, it's case insensitive. So capitalization means nothing. So it's smart enough to say, oh, I'll use the underscore instead, right? So there's a question on the chat. In MySQL, there will be automatically generate DDL code. Yeah, that's what it did. There it is. See that? It sent this command to the server. You know, just like this is Workbench. This tool here is called Workbench, and it's a user interface to send commands to the server. Right? You can graphically tell the server to create these tables and blah, 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 and do all these queries, and then graphically represent the results from the database. Well, Java can do the same thing, you know, or JPA can send commands out to the database server, and it sent this command. It sent this create. Okay, so it created the table, and so it will have the same effect as if your SQL client would have sent the commands. Right. So notice if I refresh here, you'll notice that indeed it has created a table. See that? With the columns, the correct columns. See the columns? There they are. Right. The ID, the height, the size, the text. So it created the tables for us. We didn't have to do it ourselves. Right. We just added 2 annotations, obviously the configuration, right? And it's already connected to a database, right? Which is pretty cool. Okay. Now, there's a couple things that we don't like about the default setup. Right? One of the things is that the naming convention in SQL typically is that these should be nouns, right? Which is a noun, which is perfect. Widget is a noun, but it should be plural. Instead of widget, it should be widgets. Okay. But where do we get the name? Well, we'll get the name from the name of the class, widget. So the default behavior is that it'll take the name of the class verbatim, right? Obviously, it'll make it all lowercase or all uppercase, right? Again, because it's case insensitive on the SQL side. So we're going to override a couple of things here. We're going to override the name of the table. We don't want the default name. So you can add additional annotations, right? For instance, table allows you to override the default configuration for the table, right? For instance, like the name, you can say, well, I don't want the default name. I want the name to be instead widgets, right? Plural. Okay. In Java, the naming convention is that it's a noun and it's singular and it's capitalized, right? In SQL, the naming convention is that it's also a noun, but it's plural, right? And it's all lowercase, all uppercase, or it's case insensitive. We don't care. Okay, that's one of the things we want. The other thing that we want to do is that right now this ID, the value for this primary key, right now we are responsible for that value. Right now, that value, because we're saying that it's a primary key, that means that value needs to be unique. Okay, I guess we could do that, right? We could just randomly generate it, and that's fine. We could totally do that. Or we can instead delegate it to a database and say, you know what, I don't want to deal with this. Right? You handle it. You generate these values yourself. Okay. Now, in MySQL, the way you do that is by annotating. So it would be that at the end here of this number, right, we would say, you know, auto increment, meaning start at 1, and then every time we create a brand new record, you know, just increment the value, right, of the ID. Start at maybe 1 and then go to 2 to 3, 4, 5, and so on and so forth. Or you can configure it to start at 10 and then increment by 10. So start at 10, 20, 30, 40, 50, whatever. Okay, as long as it just keeps auto incrementing. Okay, so we want to kick off that configuration, right, in the database. So, but we don't want to deal with the database. So we'll do it here from Java, right? What we're going to do is that we're going to annotate this to be a generated value. Okay, and we'll say that now different database vendors do it differently, right? So for instance, MySQL uses auto increment, right? Which starts off at 1, 2, 3, and so on and so forth, right? So this is not standard. Each database does it differently. Oracle does it using what are called sequences, right? They create they create a sequence of numbers. It's a very large sequence of incrementing values, right? And they store it and make it available so that you can pull off the next value from the sequence and then use it here. SQL Server calls it identity or something, whatever, right? So each vendor does it differently. So here you can specify the strategy. You can specify, well, which strategy do you want to use? And the one that works for MySQL is called the identity strategy. Okay, so it's generation type identity. Okay, what we'll do is basically use auto increment for MySQL. Right, let's save that. I'm going to run this again. Let's see what it does. So this is going to issue another create statement, but the table will be widgets as opposed to widget. There it is. So let's copy that. And here, let's paste it down here so we can talk about it. Okay, so same create statement, but notice that it's widgets, right? Plural. Notice that my integer is now auto increment, right? Meaning I don't have to create these integer values anymore, right? They will automatically be generated when I insert a new record. And that's it, really. That was the only difference here, right? One cool thing here is that is if I add a new field, say I add a new field, right? And I don't know, oops. And I say that, I don't know, like a description or a name. Okay, say I have a name here. And I add a new field, say code, generate the setters and getters, and I say generate the setters and getters, right? And now I run it again. If I run it again, notice what's going to happen, right? It's going to, now this time it says, oh, but the table already exists, right? I don't want to recreate it brand new from scratch. Instead, it's going to issue an alter command. See that? So send an alter command says, oh, the table already exists. I just need to add this additional field, right? So let's copy that. Let me show, and I'm just going to paste it down here. Right, it says alter widget. See that? It's altering the widgets table, and it's adding a column called name. Okay. Now, the reason it's doing that is because if you go to the application properties, we have this update here. See that? It says DDL auto. Right. So the update means I'm going to try to make incremental changes to the schema, right, to the tables, as far as I can do, because there are a few things that I can't do. I can't just update, right? Sometimes you need to just start from scratch. Right? You need to blow away the old database table, right, and start from scratch, right? Like for instance, there's another configuration called here create as a post, right? And create will always blow away the old tables, right, and recreate them from scratch, as opposed to incrementally changing them. And from time to time, right, you might have made changes to the database in such a way that you've added fields, you removed fields, you've changed data types of fields, like from integer you went to varchar, right, or vice versa, or you changed something from string to date. Okay, those changes are hard to alter, right, and sometimes it won't work. So oftentimes it's just it's better to just blow away the table, right, and start all over, right? Create will always blow away the database, right, and recreate it from scratch. And that's fine when you get started, when you don't have any data stored in the database. But if you already have a lot of data in the database, right, you definitely don't want to go with create because it'll blow away all that data, right? Instead, you want to go with update, right, for doing incremental changes. Eventually, once you're settled with the database, right, and says, okay, I like my database, I don't want to make any changes, I want it to stay the way it is, right? Eventually, you want to say none, meaning I don't want to make any changes to a database. Leave it alone, right? I like it the way it is. Don't change any data types, new fields, or anything like that. Just leave it alone, right? I'm going to use it to update. This is very convenient, as I do incremental prototyping and just try out different things. But again, eventually you want to leave it to none, right? And sometimes you're going to have to just blow away the tables and just start all over. Okay, that's very, very common. All right, so let's leave it the way it is. Okay, if we look at the table, notice that we don't have the name field here, but if I refresh, you notice that there should be a name field. No. Oh, not this one, not widget. There's widgets. There it is. Notice that I have both now. See that? I have the old widget table, the first one that I created, and this is the new widgets table, right? That has my name field in there. Okay, so I can just blow away this one. I can just say drop this table, the old one. Drop it now. So it's gone. All right, so I'm just going to keep widgets. Everybody good? Okay. All right. So if I look at the content of widgets, right, there's nothing in there. Right? I don't have any widgets stored in there. Right? I have no widgets. So how do I put data in there? I mean, I could manually do it. I could manually add widgets in here. And indeed, let's actually do that. Right? Let's do that. Let's see. Because the intent of this assignment is to replace the service here. This service. Notice this service is using what? It's using this array of widgets, right? It's using this array of widgets. We want to replace this so that it uses a database instead, right? Instead of having this data stored in this array, right? We want to blow away this array, right? And instead we want to use the database, okay? So how do we do that? Well, what we need to do is we're going to replace this data and put it in the database. Okay, so let's do that. Let's see. We have these topics. Okay, so let's do that. If we go here, let's create a record here that has that topic. We have a type. So this type here, type. Oops. Okay. We have a size 1. We have a text, welcome to widgets, text, there it is. So I've created a record, well, not yet, right? It hasn't been inserted yet. Notice that the ID doesn't exist now yet, right? But when I click apply, it actually creates the insert. See that the insert, that's the insert statement to insert that record. I'm gonna say apply. Okay, now it's in the database. I'm gonna say okay, and now it has an ID. See that? When it has an ID, it's because it is in the database, right? So let's create just a few more. Let's create these 3 here. So topic ID, 3 times. There's 3 of them. Oops. There it is. So it'll be a paragraph and 2 headings. So this one is a paragraph. Let's make this a little bigger. These 2 are paragraphs, and this one's a heading. What else? Size 1, 2, and 1. So I guess 1, 2, and 1. And what else? Okay, this is a paragraph. So the text for this one is, oops. It's that. Let's make that a little bigger. And this is for the other paragraph, which is the last one. And welcome to web dev. That's the heading here, right? There we go. Now, if I apply, because there's been 3 records that I've been working with, notice that they don't have an ID, so they're not yet in the database. Not until you apply, and it writes the insert statements to populate the database. So everything was successful. Okay, so now we have data in the database. Okay, so how do we now connect the Java code with this and replace the array? So how do we do that? So the way we're going to do that is that we're going to create what is called a repository, right? Repositories is what are going to be classes that implement all the typical CRUD operations that we would expect to be able to interact with the database, right? So we need to be able to replace all these, create, the CRUD operations, right? Create, these are the read operations, right? The updates, the deletes. We need to replace that so that they talk to the database as opposed to the array. And CRUD and a CRUD repository is going to allow me to do that, right? So I'm going to create a new directory here, a new package. Create a new package, and we'll call it repositories, right? So in there, we're going to create our widget repository. That's going to be new Java classes will be widget repository, right? And this widget repository is going to implement all my CRUD operations, right? So that I can replace my array. And the way it's going to do that is this is going, first of all, it's not a class, it's an interface, meaning we are not going to implement it. Instead, we're going to reuse someone else's implementation, which is called extends CRUD repository. See that? This one right here, CRUD repository. I mean, it's in the name, CRUD. Okay. So it implements all the create, read, update, deletes in a generic fashion, right? So it'll create a very generic implementation that can talk to any table, right? You just need to tell which table, right? You need to configure it, you need to parameterize it, saying that I want to CRUD. What is it I want to CRUD? I want to CRUD widgets. A widget, this one. So notice that it imports the widget class. We want to, which is mapped to a table. So the widget knows what table it's connected to. So the CRUD repository is going to know, oh, it's this class, which maps to that table. Or I can do that, right? I can create, read, update. I can do inserts, updates, deletes to that table. It also takes as a second parameter the primary key data type. You know, what does it use? Does it use a varchar, an integer, a long? What does it use? I believe it's a long. Okay, that's it. That's all we need to do. Now we're ready to go back and implement our service. We can rename, we can rewrite it so that it uses this repository instead of the array, right? So let's do that. So if we go to the service, where's the service? The service is right here, widget service, there it is, okay? So let's implement the easiest one, right? So let's implement these two, the find all widgets and find widgets for topic, right? So those are the easiest one. So first we'll need to bring in that brand new repository, which is going to replace this array, right? Not yet, let's not blow away the array just yet, right? So let's bring in the widget repository, which we just created, and we'll call this repository. Now, we need an instance of the repository, right? And we'll create it in a minute. So let's write this. Let's rewrite all this. Instead of using the array, which I guess we should try it, right? Let's verify this still works, right? Let's run it. Okay, it's running. It is running. So this should still work, right? This is still using the array. We're still using the array. So this will be localhost 8080. And this is API widgets, I believe. Okay, this is still using the array. We're still using the array. We want to use the database instead. Okay, so and that's implemented right here. This widget find all widgets, right? We want to use this repository. So the repository, let's bring it in. Repository is going to allow us to write this. Let's comment that out. Going to say return repository. Look at what gives us, right? So notice I say dot, and notice all these functions that are available, right? Notice that one of them is called find all. Look at that. Right, so that looks very promising, right? Find all. So find all, it like the name suggests, right? It retrieves all the records for the class or table that it is configured for. In this case, it was configured for what? For the widgets, right? So the repository, it's configured to talk to the widget. And the widget knows that it's the table widgets, right? So find all really means, you know, retrieve for me all the records for the users table. That is the default implementation, okay? Now it's complaining that it by default it returns an iterable, a widget iterable, right? Meaning something that you would need to iterate, next. But we can cast it. Notice that the return type is that it wants to return list widget. Right, so we can just cast this. We can choose cast. That's it. We're done. Okay, let's restart the server. Oh, one more thing. We need an instance of this guy, right? Now we have a couple ways of instantiating it. We don't want to do this new widget repository, right? Which is normally widget repository. Wait a minute, what? Well, one of the reasons you can't do that is that widget repository is an interface, first of all, right? So you can't instantiate it. And so instead, what we're going to do is that we're going to ask the infrastructure to fabricate one of these things for us, right? It's a now we don't want to be responsible for the creation of these things. So instead, we're going to delegate it to the infrastructure, where you're going to create an instance of this thing, right? And you're going to inject it and make it available here at that variable, right? It's a design pattern called Inversion of Control, where I establish a dependency and say, hey, I depend on this, make it happen, right? The infrastructure, you instantiate whatever you need to instantiate, and then pass me a reference to it. And one of the reasons is that we're doing it this way is that this repository, we want it to behave like a singleton. A singleton is a design pattern where there's only a single instance of something that is shared amongst the entire infrastructure, right? Usually these are very expensive types of objects that you don't want to have a whole bunch of them instantiated hanging around in the system. Instead, you usually just have one of them, and then you share it amongst everybody else. Okay, and for instance, if you have a connection to a server or connection to a database, things like that are very, very expensive to instantiate, and it's not a good idea for you to manage them, right? Because they're enterprise-wide objects, right? And you should not have the responsibility of managing its life cycle. You instead delegate it to the infrastructure. So the way we're going to do that is that we're going to use AutoWired. So AutoWired is going to say, well, you create an instance of this and provide its reference here. All right, let's restart the server. So if we restart the server, hopefully this will behave just like it was before, but instead of retrieving the data from the array, it will retrieve it from the database, right? Okay, it's up and running. Let's try and hit this again. So let's refresh. Okay, it looks like it worked, right? Notice that the IDs, these IDs are coming from the database, right? ID 1, 2, 3, 4, right? Now, if you don't believe me that this comes from a database, let's create another record. Let's create another record here. So there's 4 of them. So there's 4 here. Let's create a 5th one. Right, let's create another one for topic ID 1, 2, 3. Okay, and so this will be a paragraph. And this, the text will be "believe me," and the size will be 2. And anything else? So apply. So created. If I go back here and I refresh, notice that I do have that 5th one in there. See that? So it is indeed retrieving the data from the database. Okay. Perfect. Excellent. So we did that one. What about all the other ones? All the other ones. So for instance, we would like to also replace this one, right? The one that retrieves the widget for a given topic, right? So how do we do that? Well, actually, no, let's leave them for a little later. Let's do this one, find widget by ID. So in this one, basically what we want to do is that we want to replace the fact that we're using this array. We don't want to use the array anymore, right? We want to, retrieve the ones for topic ABC. I mean, give me the particular ID, and I'll retrieve that one object, Okay. So how do we do that? Well, again, the Crud repository also has availability of being able to retrieve one individual object. Right? So if we do return here, and we use the repository instead, we can say repository dot find. Notice that there's a find by ID. See that? Notice that all these functions are very generic, right? It says find by ID. Find what by ID? Well, I don't know. Well, whatever you configured me to find, right? I am configured to find widgets, right? But the names of the functions need to stay generic, right? And the configuration happens when you in the declaration of the Crud repository, right? So you pass the ID, and that's it. Actually, not that's it, right? This comes back with a wrapper object that can be used for validating whether data came back from the server or not. Okay, so we need to unwrap that object by just plain old using get.get. .get retrieves the inner object, which happens to be a widget. Okay, so let's try it out. Let's run it. All right, so let's see, let's refresh. Okay, it's not done, not yet. And I believe this one was mapped to /API/widgets/ the ID of the widget that you want. Okay, so let's retrieve number 1. So I think it's widgets/1. And notice that it retrieves that one widget. So that's working. Right? Let's retrieve the brand new one that we just created, 5. So it says widgets/5. Retrieves that one widget. All right, excellent. Let's keep going. Now, this is using, notice that it's writing to the command, to the terminal in the run. It says, it's showing the query, right, the SQL that it's using to communicate with the server, right? This is the queries that I'm sending over to, so the SQL queries that to retrieve the data, and I'm converting into Java instances, and then converting into JSON strings, right? Well, you can override that. You can override that and say, well, I don't want to use your queries. I want to use my queries. Okay, so for instance, we can override this. We can override these find all. Instead of it using its own implementation, we can say what query you want. For instance, and the way you do that is you go back to repository and say, well, instead of you using your magical query to retrieve all the records, I want to use mine, right? So I can implement the find all by saying the query that I want is, select star from widgets where ID is equal to some placeholder that you're going to pass me. Okay, and the way I'm going to invoke this this query is I'm going to wrap it inside of a function that is going to return a list of widgets. I'm going to call it find all widgets. Notice that now I can give it whatever name I want. And notice I'm not going to implement it. I'm just going to say, when I call this function, I want this query to execute. Okay. Also, this is a native query. True, meaning I want to verbatim, I want you to use exactly this query, as it is configured here. And I'm going to pass you a parameter for this, right? I'm going to pass you a long widget ID. I'm going to pass you, and I'm going to map that parameter to a parameter in the query that we called WID. See that? Okay. So now that I've implemented that, I can go back here, and instead of using this default implementation, I can use mine. I can return instead repository.find all widgets that I just built. Okay, and it's going to use that underlying query. I'm sorry. Find all widgets doesn't take arguments. Sorry. This is for find widget by ID. There we go. That one. This one is this final widget takes no arguments, right? So this just says, select star from widgets and nowhere. I want all of them, right? Whereas this one is, I want just that one that has that ID. So now I can go back and rewrite this. It says final widgets would be that one. And I can rewrite the other one here. I can rewrite it using my brand new return repository dot find widget by ID, and I can pass in the ID. And this returns one widget, not a list of widgets. Okay, we can restart. And if we refresh, notice that it works just the same, works identical. Question in the chat says, could you explain more why do we use native query? What would happen if it was false? Yeah, okay, let me show you. So there's an alternative language. Okay, this is native SQL. This is native SQL, right? And it's useful if you want to write exactly what you want to send over to the server. There is a higher level language called Jpql. Let me show you. So I'm going to comment that out, right? There's a higher level language that it is the default, which is not native. Right? It's not native. That is more object oriented, right? That looks like this. I want to select a widget which are of type widget. Okay. Notice that this is much more object oriented, right? So select widget, which these widgets are of type widget. Okay, and this is the class widget. Notice that there is no mention of the table widgets. See that? The only reason we know that this maps to a table called widgets is because widget is mentioned here, that the table is widgets. That's the only way that we know that this class widget maps to a table widget. But here, this higher level language, right, allows you to think in the object world as opposed to thinking in the SQL world. Okay. There's a question in the chat. Is this rewriting just a proof of concept, or is the default implementation not desired? Well, no. The default implementation is preferable, is it desirable. I wanted to wait before covering it, since most of you, if you are already familiar with SQL, you'll be familiar with this, and so I didn't want to yet talk about this just yet. But since it's a little more advanced, and native query works just as well. Let's see. There's what's the difference between using the built-in method or the self-implemented method? You mean? I'm guessing you are comparing whether you're using this or you're using this, the generic one, right? Do we want to use this implementation or this implementation? Well, the reason I'm introducing this, right, is that you already sort of know what this is doing, right? And it's implementing this. And if you don't have to, you can absolutely use the out-of-the-box versions, right, like we did earlier. It was meant for me to introduce now this over here, find widgets for topic. Find widget for topic, there's a relationship between these two, right? So now we want to retrieve things for a topic. There is no default implementation for this, right? You need to implement this out of completely yourself, right? This will be select widgets where, right, the topic ID I'm passing you as an argument, right? You have to implement your own. Right? So I wanted to first cover easier ones like select star, right, with no where, then where with ID, and now we'll do for topic, right? So let's do that. Okay, so I want to implement this in the repository. So in the repository, I want to implement something like this, right? Public, give me the list of widgets, right, for a topic, right, where I'm going to pass you a string, which is my topic ID. Okay, so I would implement that. So the query for that would be what? It would be query. The string would be select star from widgets, widgets where topic, and this would be the field topic ID, right, is equal to TID, right? Where this column is this column over here, this column right here. See that? Okay, and so this is a value, and this is native query. Native query is true. And now I can pass you as a parameter to this. I want to pass you this, so I'm going to just implement that and map it, TID, like that, and that's going to filter those widgets for that specific topic. Okay, once I've implemented that, I can go back here and I can comment this out and say that this is going to return the repositories.find widgets for topic, and I'll pass you the topic ID. There we go. See that? So let's run that again. Right, so that's going to restart the server, and now I should be able to pass you the topic ID and filter those topics by whatever criteria I want. My criteria is by topic ID, but you could have any ID topic criteria. You can filter by size, right, by width, by height. You can do whatever you want, right? You can implement whatever query you want, right? So if I go back here and I retrieve all the widgets, let's see, we can retrieve the ones for topic ID ABC123. So this would be topics, and there they are, right? So these are the ones for ABC123. See that? Right? Or I think we had another one, 234, I think. There we go. So we'll get the 3 from that topic ID. Make sense? All right. So we've talked about retrieving data. What about creating brand new data, right? So let's take a look at that. Right, so for instance, right, we want to be able to delete a widget. Right? So deleting a widget, we want to replace this. And so how do we replace it? Well, the repository has a delete by ID. See that? Right? We can just say pass in the ID. Right, and that will just delete it, and we're going to return a 1. We're just going to, by default, we're just going to return a 1. Success. Okay. Well, the only way to test this is to actually run the client side of this, right? So let's do that. Let's first restart this, and let's open up a recent the React. Where's the React? This one is React, right? So as the React, let's start the React. Where is it? Where did it go? Oh, here it is. Let's start it. Let's see. That's not it. Oh, I guess this is not the project. Sorry. Oh, this is a prototype. Let me close this. Open recent. So this is sp blah blah blah. I think it's this one. Yeah, that one. Let me run it. All right, there we go. So we go to a particular course. Oops, sorry. Let's go to a particular course, and I don't know if any of these has widgets. Okay, this one has widgets. All right, okay, these are the two widgets that we had earlier, right? And presumably these are coming from the server. These are coming from the server. And just to verify, we can go to the widget list, right? And just print out over here maybe the ID of the widget. Say here. Maybe not. Let's see, widget, blah, blah, blah. widget list. This is this one. Okay. The key widget. Blah 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 blah. Why are you not? Oh, it's widget. There we go. Okay. These are the IDs, right? So this is ID number 2, which is this one, right? ID number 2 is this one. This is a paragraph. This is a paragraph. Okay. So let's delete it. We'll say click here, and we're going to delete. Let's come here and let's refresh, and notice that the widget is gone. Right. So we are deleting from the database. Perfect. Right. How about updating a widget? Right. So updating a widget. Well, actually, no. Let's do create a widget. Let's do create a widget. So we go back to the database, right? Instead of creating this, right, and pushing it into the array, what we're going to do is that we want to save it as a new record in the database. So let's do that. So it's going to refresh that, and instead we're going to replace that with return. We'll grab the widget and we're going to save it into database. We want to insert it in the database, and that's very easy using the repository. We can say repository dot, notice that it has save. See that save? This is very smart. It knows that if the record doesn't already exist in the database, that it will be an insert. All right, let's do that. We'll do save and then widget. That's it. Right, this will insert in the database, right, and return the record that was just inserted. Right, so let's restart. Okay. All right, so let's refresh. There they are. And so let's create a brand new one. Let's see, how many do we have? We have, let's see, there's a question here. Does the out of the box delete return anything? No, it doesn't. It returns void, unfortunately. So we have, how many do we have in the database? We have just 1, 2, 3, 4. Let's create one here. Okay, so presumably created a brand new heading widget with size 6. So, and I'm sorry, the ID is 6. So let's refresh, and notice that indeed it created a brand new record in the database, right? New widget. The text is new widget. There it is. See that? All right, excellent. So we can create, we can delete, we can retrieve data. Right. The very last thing that we need to learn how to do is being able to update data that is already in the database. Right. So to do that, we are going to, here in the updates, right, instead of using the array, the way it works is that we use the ID to first retrieve the data from the database, retrieve the document from the record from the database, right? So we say widget. So this is the original widget, right? We use the function that we wrote earlier to retrieve that record, right? So we can say, find widget by ID. We pass in the ID. Now we have the record that is loaded from the database right here, right? And now we can update it and manipulate it. We can say original widget dot set, let's say the text, right? We can change the text, then change it and set it to be whatever you passed in, the new widget, the new data that you are sending over. And this is a widget dot get text. And so basically we're copying from the new widget to the original widget, right? Once we do that, we can save it back to database, right? And the way we save it is that we use the same repository. We're going to return whatever the repository does to save the record back to database, right? So this will be, we're saving the original widget back to the database, right? So now this is going to do an update, right? The previous save did an insert because it knows that this is a brand new record that doesn't exist in the database, so it needs to be an insert. Whereas this one, right, it knows that this is a an object that it got from database, right? This is not something that you passed it. If we were doing a save on this object, it would do an insert. But because we're doing a save on something that we retrieved from a record in the database, then it knows that it needs to be an update and not an insert. Okay. Also here we are sending, well, you could return whatever you want here, or I guess we don't have to return. If you return, it'll just return the new object, right? I'm sorry, the object that it retrieved from the database, but with any attributes modified, right? So I guess we don't have to return it. Whatever, however you wrote it in from the client, you can just return 1. Okay, so if we restart, let's see if it updates. Okay, so if we go back here and we edit this, let's see if we can edit the lorem ipsum, and maybe we can. Oh, I guess we never implemented the update on the client side, right? So yeah, let's fix this on the client side. Let's see. Let's go on the React side here, and here we have the update, and I'm going to say okay. Okay, notice that if we refresh and we go number four, we go to the database, and it used to be lorem ipsum, and if we refresh, notice that it has changed to be lorem ipsum, lorem ipsum. Okay, so there we have it, right? So we can implement all the CRUD operations using the database, the repository. Right now, we should be, since we've now replaced all uses of the array, we should be able to just remove the array entirely. Right? Let's make sure. Let's see. We have the create widget for topic is not using the array anymore. The find all widgets is also not using the array. Find widgets for topic is not using the array. This one neither. There's the update doesn't seem to be using the array either, and delete is also not using it. Right? So we should be safe to just remove the array entirely. There we have it, right? And if we refresh, let's verify that indeed it's working without, it compiles without the array. All right, let's refresh, and we can create. Let's see, create several headings widgets. All right, so it looks like it's working, right? And let's see if it's being inserted. Okay, perfect. It is inserting the database. Perfect, excellent. So that's the database part of the assignment. The next part of the assignment, says, okay, well, now that you know how to do that, right? Let's work on a couple more widgets that are just a little bit more challenging, right? So you worked on 2 types of widgets already, which was the paragraph widget and the list, the paragraph widget and the heading widget. So this time around, you're going to work on 2 new widgets. You're going to implement the list widget shown here on the right-hand side. Okay, like all the other widgets, it has a, it renders as a HTML DOM, right? And the list widget can either render it 2 ways. It could render as a bullet, right, which is unordered using UL, or it can render as OL. Okay, and you can configure the items. You can say which items you want to display, and also whether it renders as a unordered or ordered by clicking on the cog. Right, so if you click on the cog, it opens up as in its edit form, right? And you have a checkbox that allows you to choose whether the list should be ordered or not. Right? By default, it's unchecked. It's unchecked, and the items are maintained as a putting each item in 1 line. in each line, right? So for instance, you can have the item. There are two type of, that's one item, the first item, lists, ordered, and then another item, and so on and so forth. So notice that this is item 1, 2, 3, 4, 5, 5. You click on the cog, right? This is what you see. Right? It's ordered, right? Because it has 1, 2, 3, 4, 5, and each item is listed in each line of the text area. So it's a text area. Meaning you can type whatever you want in the text area, but each line, right, indicates an individual line item. Make sense? Okay. Obviously, if you click on the trash can, it blows away the content, right, and removes it from the database. If you say OK, right, it re-updates, right, it saves it in the database, and you see the update immediately here in the list. Okay, so that's one of them. The second widget that you're going to build on is the image widget. So the image widget is going to allow folks to embed images as part of the content, right? So you can create headings, you can create paragraphs, you can create images or lists, right? And the images are fairly simple. They just have three fields, right, that allow me to configure what image I want to display here. So notice by default, it just displays an image, and it has a cog here that allows me to configure it. When I click on the cog, it displays three fields: one for providing the URL of the image that you want to display, and two other ones to configure the size of the image, either width or height. Okay. Now, this image doesn't mean that this image needs to be uploaded anywhere or that you need to store this image in the database. No. The only thing that you're storing in the database is the URL, right? Not the image itself. Okay, the image stays, wherever it was, right, in whatever server it lives on, right? Here, you just copy and paste the URL of where it is on the network. Okay, and when it renders, right, you use that to configure the source of the img tag. Okay, and it renders that particular image. That makes sense? All right, excellent. So that's all there is, right? I'm going to push the code that I have here. I pretty much did all the homework for you. Okay. Yeah. So basically, what most of you are going to be doing is trying to get this up and running on your machine, and what the challenge will be, obviously, to get this configured, that the JPA libraries download, that the MySQL gets connected. You'll need to download MySQL and configure it to run on your machine. You don't have to deploy this. This doesn't have to work in the remote server. It can work locally on your machine. And next week, right, we will take a look at configuring the remote database on a remote server like Heroku or AWS. Okay, so for this week, yeah, don't worry about it. You can have the database server running on your local machine. Next week, we'll have you configure it and have it run on a remote database. Okay, so that'll be next week. All right. Any questions so far? All right, so if there are no questions, I'd like to open it up for questions, and if you need some help working on the assignment, I can help out folks for another 15 minutes. Will you demonstrate the rest of the widgets implementation in class? We could totally do that. Is that something folks want to take a look at?
Professor?
Yes.
I want to ask about the assignment 5, about the topic. We did that the topic IDs are in the generic server in assignment 4, but during the class you create some dummy ones which ID is ABC 2, 3, 4 like this.
Right.
So when we're doing assignment 5, whether we are using some dummy ones like you did on the class or the previous one we create on the generic server.
Oh no, yeah, yours have to be real topics. Yeah, I didn't have any topics. I had not implemented the topic side of the assignment, so that's why I created some dummy values. But yours has to work with real topics.
Okay, so we are going to use the ones we create during assignment 4, right?
Yes.
Okay,
correct.
thank you.
All right. Yeah. So let me demonstrate getting started with these two widgets, right? So what we did last week, right? We had created in a directory here in the widgets. We had created we're putting all widgets in there, right? So we have the heading widget, the paragraph widget, right? And each one provided the form to edit the widget. Okay. So let's do that. Let's create here the two new widgets. One of them is going to be the list widget. Okay. And so let's get started. So this is an import React from React. And this is going to be list widget. This is going to return widget. And this is going to be h2. So this is list widget. And we're going to export default list widget. Okay. And I'm just going to copy this, and this is going to be the image widget. Okay. So this is going to be image. Okay. And so in the list widget, basically we're going to render one or the other depending on the type. Okay. So I can just copy one of these. And if this is a list, then this is renders list widget. And if this is what was the other one? Image, then this renders the image widget. Okay. All right. So we can now, right now we don't have any image widgets, right? We don't have any list widgets, but that's okay, right? We can go back to our database and just create a few. We can say that some of these are image, and these are list. Because remember, now the data is coming back from the database, right? And these all belong to topic widget 234. So let's, if we go back here to the UI, what is it? We refresh. Widget 234. And some of these, I think, let me just remove a few of these. Let's see, 6, 7, 6, 7, 8. So 6 is an image widget. 6 is an image widget, but it's not rendering as an image widget. Wait a minute, what's going on here? So 6 edits, and it's rendering, let me display the type. Did I not? Let's see, there's a question in the chat. You have to click apply in MySQL. Didn't I click apply? I have the IDs here. Oh, I'm sorry. I didn't update. Thank you. Thank you. Yes. Let's refresh. Okay, there we go. Image widget and list widget. Okay. So if I click on edit, right now the edit is not doing anything, right? Right now it's not doing anything. So the we could do, just like we did for the heading widget, we can we have an editing that is going to allow us to choose to display the editing format or not. Okay, so if we are editing, we show this. If we're not editing, we don't show it. Okay, so let's do that. So we're saying that if we're editing, let's copy this. If we are editing, we show, so editing. We use a checkbox, right? So that we can choose whether it's ordered or not. So he's going to say, an input of type checkbox. Okay. And a label that says ordered. All right. And we'll close that. Plus, we run a text area down below it, right? So text area. And I think we want to label that starts off as saying what? Let's see. This. I'm going to put this here. That says here list items, right? So this is list items. Yeah, let's see what this renders as. Let's refresh the list widget here. Okay, there it is. So we have our checkbox and our list items. So we need to make this a little prettier. We can use here this form control. So it takes up the entire width of the screen. And we might need a break here. List widget over here, right? There it is. Okay, that looks a little better. And then we can type in here. We can make this a little bigger. Right? We can say that the rows is maybe 10 rows. Right, so it's pretty big. So enough place for us to type. Now the image widget should behave the same way. We're going to grab this, and in the list widget, in the image widget, we have the same thing. We're going to say that if we're editing, we're going to display three fields, right? One for the URL. So input, and this will be, they're all going to be class form control. And there are going to be three of these. One for the URL, one for the width, and one for the height. Okay, so on the image widget, if I edit, right, it shows all three. See that? Okay. And as you save, right, you basically call. You have a set widget that allows you to set each one individually, just like we did for the heading. Right? We can say set widget, right, and pass in the values for each one of these. Right? So the value for each one of these, right? So this would be value, would be widget width, right? And we can do the same thing for this one. This is height. Okay. And this one is, I don't think we have a URL for this. We don't have a field URL for this, right? So we would need to add a field URL. We don't have that, but let's add it anyway. So this will be value URL. And let's see what this would display. It doesn't display anything, but for 7, let's add some values in the database, right? So let's go back to the database. And we have width and we have height for number 7. So let's add some width here. So let's do 200 for image, and the width here is 300. Okay, let's update. So if we refresh and display that, notice that we have that value. See that 200 and 300? That's coming straight from the database. See that? Okay. For the list widget, What we could use here is the text. The text can be the actual content that we can use as a for rendering, right? So for number 8, we don't have any text. For number 8, so let's put some text here. So text, here's a text, right? We'll say item 1, and then we could use new line as a means of subdividing the items, right? So item 1, item 2, new line, and item 3, right? We're gonna apply. There we go. What happened? Did it work? Let me see. Item. Oh, it didn't take it. I think it didn't like that. Actually, let me copy this. So if I say item 1, item 2, and item 3, copy that, and I put it in here. I say enter, and I apply. Okay, so that worked. Right, so let's retrieve that data and display it. Right, so items is that value. So let's go into the list widget. We can say that the text area, the value will be the widget.text. Okay. And let's see, number 8. There it is. These are the items. See that? So those items, we could use it to render the widget, right? When we're not editing, when we're not editing, we can say when we're not editing. We'll say if we're not editing, right? We want to display what? We want to display UL. Well, depending on the type, right? If it's ordered or unordered. And then we can iterate over the line items. And the line items would be what? Would be you iterate over the widget text, widget.text. We want to split on the new line. And then this comes back as each one of the items. And then we render line items, and then we display the item. Okay, so that if we say okay, notice that it renders as bullet points. See that? Bullets if this is unordered, or ordered, or it would be ordered if otherwise. Make sense? Okay. If you edit it, it displays the items. If you're not editing, it displays the ordered items. And this would be based on whether the type, right? If it's ordered or unordered. So you would need in the data model, for the widget, you would need to know whether it's ordered or not. So this would be, private Boolean ordered, right? There was another one that we need, the source, right? So source for the image. So source for the image. Let's create those two and say code generate both. Okay, and if we refresh over here, it should create. Oh, I need to restart. Let's restart the server. It should alter and add those two new fields, right? A Boolean ordered field and a varchar source. There it is. See that? It added ordered as a bit, 0 or 1, and then source as a varchar. So if we refresh here, notice we should have two new columns, ordered and source. So for the list widget, right, we can say this one we can say ordered. We'd say 1, and this one might be 0, right? So those are not ordered. So we could take these two items and maybe replace this with, say, A, B, and C, and apply. Oops, something didn't like it. Ordered. Ordered. These are not strings. These are not strings. Always have I don't know what it doesn't like. Apply, update, apply. Let me refresh. Okay, looks like it worked. Okay, so here, back of the UI, we can check to see if it's ordered or not. So this one we might say, if it's editing, we can decide to do one or two things, right? We can say, we can put this in here. We can say, if it's ordered, so ordered, widget dot ordered. If it's ordered, right, we render this. Or if it's not ordered, right, if it's not ordered, we can render this version. Okay. All right, let's try it out. Let's see if this blows up. Let's refresh. Okay, so this almost worked. This almost worked. Looks like let me add the new lines probably. Oh, it's not gonna let me edit it, is it? Or let me just add a simple text area so I can just type it, type the value. Text area. There we go. And just add here. Just copy this so I can paste it in the database. Copy and put it in the database. Apply. Oh, see that adds the new lines? See that the new lines, how it separates the values? That's how text area separates the values, right? So now, okay, we can comment this out now. We go back and refresh. Notice that indeed, see that this is rendering as ordered, right? Because of the bit is 1, it's true, and this one is false, right? So it's rendering as unordered. Make sense? All right, excellent. So that's all, folks. That's a new assignment for this week. Can you quickly show your server-side update widget again? Sure. Yeah. So for the update widget, the only thing that we're doing is that we're copying. Right now, we're only copying the text, but you can certainly copy other things, right? You can copy the source, right? And get source. Now, the thing is that this might be null, right? So you have to be careful, right? So probably you want to put an if statement here, checking to see that if the source is not null, then you want to do the copy. If not, you don't do the copy. Otherwise, you'll get like a null point exception, right? So you want to do the copy, if it's safe. If not, then you can leave it alone. If it's null, that's fine. It doesn't care. Okay.
Hi, Professor. I had a small question.
Yes.
Professor, I was just reading on the internet, and a lot of people use Next.js with React.js. So is it beneficial, Next.js with React.js? And just some questions I have in my mind.
Say it again. To mix what? You're breaking up. Hello? Hello? Right. Why don't you maybe call me or chat me or text me, and then we can chat offline, okay? All right, this looks like the question in the chat. Can we have our widgets be instantiated with an empty string or source? Yes, source. Not all widgets need source. So yeah, so that totally can be an empty widget or null. If it's not an image, then yes, certainly. All right, guys, thank you. I'm going to push this so you can take a look at this. All right. Yeah, I'll push this right now.
Thank you,
Thank you.
Professor. Have a good one.
Bye-bye. Take care.